Write the polynomial f of x equal 2x cubed minus x squared plus 36x minus 18 as a product of linear factors, then find all zeros. Let's try to factor it first. We can count the terms. There are 1, 2, 3, 4 terms, so let's try to factor by grouping. I can group the first 2 terms together. I can group the back 2 terms together. Let's try to factor each piece. Factor this first part. I can pull out an x squared. There's x squared in each term, so I have 2x minus 1. If I factor the pair I've underlined in blue, I can factor out, looks like an 18. So I also have 2x minus 1. Remember that when you're factoring by grouping, it is ideal to have whatever you have remaining in your first set should also be remaining in your second set, or you need to do something else. Try something, switch some terms or the order or something. So now both terms have 2x minus 1. So I can take what they have in common, which is the 2x minus 1, and I can read off the rest. Hopefully you can see by when I color-coded, this is how I factor it. But I want a product of linear factors. So I need to try to factor this further. I see I have 2 terms, and I have a plus in the middle, so I really can't factor this over the real numbers. My answer is going to be complex. I have a factor theorem that says if x equals c is a 0 of a polynomial, then x minus c is a factor. If x equals c is a 0 of a polynomial, then x minus c is a factor. And vice versa. If x minus c is a factor, then x equals c is a 0. So I can say, well, I have x squared plus 18 equals 0. So x squared equals negative 18. I can take the positive and negative root of both sides. We're trying to pull out perfect square factors, so let's try to factor this. We can write this as plus or minus 3 root 2 because I have 2 of these. So if I put all this under a root, square root of 18 is square root of 2 times 3 times 3. This pair comes out as a single 3 root 2. And I have an I back here because that was a negative. Don't forget that negative right there. So I end up being able to factor this as f of x equal 2x minus 1 times x minus 3 square root of 2 times I times x plus 3 square root of 2 times I. Because if these are zeros of a polynomial, then I know x minus 3 root 2 I and x plus 3 root 2 I are factors. So here is the product of linear factors right here. And all the zeros. X equal 3 root 2 times I. X equal negative 3 root 2 times I. And then if I solve 2x minus 1 equal to 0, x equal 1/2.